Class 1 Division 2 hazardous locations are areas where flammable vapors, gases, or liquids are present in the air but are normally absent, or present in only minute quantities, and are not likely to ignite and propagate an explosion. Alternators operating in Class 1 Division 2 hazardous locations must meet several requirements. Firstly, they must be listed by a nationally recognized testing laboratory, or NRTL, such as UL or CSA, for use in the specific hazardous location. Secondly, they must have an M4X or I65 enclosure to prevent the ingress of dust and moisture. Thirdly, they must have a spark arrestor or other device to prevent the emission of sparks. XN alternators are suitable for use in Zone 2 hazardous areas in Europe. They comply with the EN 50021/1999 and are certified as Type X and a Roman 2T3, indicating that they are non-sparking and safe for use in Zone 2 areas. The automatic voltage regulator, or AVR, must be installed within an XD Zone 2 enclosure to ensure protection against hazardous vapors. IP56 totally enclosed fan-cooled, or TEFC, alternators are not intrinsically safe and are not suitable for use in Class 1 Division 2 or Zone 2 hazardous locations without additional protection. They have an IP56 enclosure rating, which means they are protected against dust and water ingress, but they do not have spark protection. Using IP56 TEFC alternators in hazardous areas requires additional measures, such as installing them in a purged enclosure or using a spark arrestor. To ensure compliance and safety, it is best to use XN alternators that are certified for use in Class 1 Division 2 or Zone 2 hazardous locations. This eliminates the need for additional protection measures and ensures that the equipment meets all applicable standards. Understanding the specific requirements for alternators in hazardous locations is critical for maintaining safety and preventing explosions. It's important to distinguish between different types of alternators and their suitability for various hazardous zones. XN alternators are designed with features that minimize the risk of sparking, while IP56 TEFC alternators typically lack these intrinsic safety features. The role of nationally recognized testing laboratories in certifying equipment cannot be overstated. These laboratories rigorously test and evaluate equipment to ensure they meet the stringent safety standards required for hazardous locations. Their listing provides assurance that the alternator has been properly assessed and is suitable for the intended environment. Enclosure ratings such as NEMA4X or I65 are another crucial aspect of alternator safety. These ratings indicate the degree of protection provided against environmental factors like dust and moisture, which can compromise the integrity of the equipment and increase the risk of hazards. Spark arrestors are essential devices that prevent the emission of sparks from the alternator, which could potentially ignite flammable substances in the surrounding atmosphere. These arrestors typically incorporate designs that quench or contain any sparks that may occur within the alternator. In Zone 2 hazardous areas in Europe, XN alternators are specifically designed and certified to comply with the EN 50021/1999. This standard outlines the requirements for electrical apparatus intended for use in areas where explosive atmospheres are likely to occur. The certification of Type X and a Roman 2T3 further specifies the alternator's suitability for Zone 2 areas, confirming its non-sparking characteristics and temperature rating. The automatic voltage regulator plays a critical role in maintaining stable voltage output from the alternator. In hazardous locations, the AVR must be housed within an EXD Zone 2 enclosure to prevent any potential ignition sources from escaping and causing an explosion. EXD enclosures are designed to contain any internal explosions and prevent them from propagating to the external environment. IP56 TEFC alternators, while providing protection against dust and water ingress, do not inherently possess the safety features necessary for hazardous locations. These alternators typically lack spark protection and may not be suitable for use in areas where flammable substances are present. To utilize IP56 TEFC alternators in hazardous areas, additional protection measures are required. These measures may include installing the alternator in a purged enclosure, which uses clean air or inert gas to maintain a safe atmosphere around the equipment. Alternatively, a spark arrestor can be added to the alternator to prevent the emission of sparks. In summary, The selection of alternators for hazardous locations should be based on a comprehensive understanding of the specific requirements and applicable standards. XN alternators, with their intrinsic safety features and certifications, are generally the preferred choice for Class 1 Division 2 or Zone 2 areas. When considering the use of IP56 TEFC alternators, it is essential to implement additional protection measures to ensure compliance and safety. Compliance with industry standards is not merely a formality, but a critical aspect of ensuring the safety of personnel and preventing catastrophic incidents. Regular inspections and maintenance of alternators in hazardous locations are essential for maintaining their integrity and ensuring their continued compliance with safety standards. This includes verifying the proper functioning of spark arresters, inspecting enclosures for damage, and ensuring that all electrical connections are secure. When replacing alternators in hazardous locations, it is crucial to select equipment that is specifically certified for the intended environment. Using non-certified equipment can create a significant safety risk and potentially violate applicable regulations. Understanding the specific requirements for different types of hazardous locations is essential for selecting the appropriate equipment. Class 1 Division 2 and Zone 2 areas have distinct characteristics and require different levels of protection. By carefully considering these factors, it is possible to ensure that alternators are operated safely and reliably in hazardous environments. The selection of appropriate alternators for hazardous locations is a multifaceted process that requires careful consideration of various factors, including the type of hazardous area, the applicable standards, and the specific characteristics of the equipment. By following these guidelines and adhering to industry best practices, it is possible to minimize the risk of explosions and ensure the safety of personnel working in these environments. When evaluating alternators for hazardous locations, it is important to consult with qualified professionals who have expertise in this area. These professionals can provide valuable guidance and assistance in selecting the appropriate equipment and ensuring compliance with all applicable regulations. The installation and maintenance of alternators in hazardous locations should only be performed by qualified personnel who have received specialized training in this area. These personnel should be familiar with the specific hazards associated with the environment and the appropriate safety procedures. In addition to selecting and installing the appropriate equipment, it is also important to implement a comprehensive safety management system that includes regular inspections, maintenance, and training. This system should be designed to identify and mitigate potential hazards and ensure that all personnel are aware of the risks involved. The use of technology can also play a significant role in enhancing safety in hazardous locations. For example, remote monitoring systems can be used to track the performance of alternators and detect potential problems before they escalate. These systems can also provide real-time data on environmental conditions such as temperature and humidity, which can help to identify potential hazards. In conclusion, the safe operation of alternators in hazardous locations requires a comprehensive approach that encompasses equipment selection, installation, maintenance, training, and safety management. By following these guidelines and adhering to industry best practices, it is possible to minimize the risk of explosions and ensure the safety of personnel working in these environments. Remember that safety is paramount in hazardous locations, and no effort should be spared to ensure that all equipment and procedures are in compliance with applicable standards and regulations. Continuous improvement is essential for maintaining a safe working environment, and regular reviews of safety procedures and practices should be conducted to identify areas for improvement. Collaboration between engineers, safety professionals, and workers is crucial for creating a culture of safety in hazardous locations. By working together, it is possible to identify and mitigate potential hazards and ensure that everyone is aware of the risks involved. Ultimately, the goal is to create a working environment where safety is always the top priority and where everyone feels empowered to speak up if they see something that could potentially lead to an accident. Consider that the information provided is for general guidance only and should not be considered a substitute for professional engineering advice. Always consult with qualified professionals before making any decisions about the selection, installation, or operation of alternators in hazardous locations. Failure to do so could result in serious injury or property damage. It's also important to stay up to date on the latest standards and regulations related to hazardous locations, as these are subject to change. Regularly review and update safety procedures and practices to ensure that they are in line with current requirements. The selection and operation of alternators in hazardous locations is a complex and challenging task, but it is also a critical one. By taking the time to understand the risks involved and following the appropriate safety procedures, it is possible to minimize the potential for accidents and create a safe working environment for everyone. Consider the specific application for the alternator and the requirements of the load it will be serving. This will help to determine the appropriate size and type of alternator for the job. Also, factor in the environmental conditions in which the alternator will be operating, such as temperature, humidity, and altitude. These factors can affect the performance of the alternator and should be taken into account when selecting the appropriate equipment. Inspect the alternator regularly for any signs of damage or wear and tear. This includes checking the windings, bearings, and other components for cracks, corrosion, or other defects. If any problems are found, they should be repaired or replaced immediately to prevent further damage or potential hazards. Lubricate the alternator regularly according to the manufacturer's recommendations. This will help to keep the bearings and other moving parts in good condition and prevent premature wear. Keep the alternator clean and free of dirt, dust, and other contaminants. This will help to ensure that the alternator operates efficiently and reliably. Provide adequate ventilation for the alternator to prevent overheating. Overheating can damage the alternator and reduce its lifespan. Monitor the alternator's performance regularly to detect any signs of problems. This includes checking the voltage, current, and frequency of the output. If any abnormalities are detected, they should be investigated immediately to determine the cause and prevent further damage. The proper grounding of the alternator is essential for safety. Make sure that the alternator is properly grounded according to the manufacturer's recommendations and applicable electrical codes. Use only qualified personnel to install, maintain, and repair alternators in hazardous locations. These personnel should have the necessary training and experience to perform these tasks safely and effectively. Follow all applicable safety procedures and regulations when working with alternators in hazardous locations. This includes wearing appropriate personal protective equipment such as gloves, safety glasses, and hearing protection. Be aware of the potential hazards associated with alternators in hazardous locations, such as electric shock, fire, and explosion. Take the necessary precautions to avoid these hazards. Never attempt to repair an alternator while it is energized. Always disconnect the power supply before performing any maintenance or repairs. Use only approved parts and materials when repairing alternators in hazardous locations. Non-approved parts can compromise the safety of the equipment and potentially lead to an accident. Keep a record of all maintenance and repairs performed on alternators in hazardous locations. This will help to track the performance of the equipment and identify any potential problems. Regularly review and update safety procedures and practices to ensure that they are in line with current requirements. Consider the specific application for the alternator and the requirements of the load it will be serving. By considering these factors and following the appropriate safety procedures, it is possible to operate alternators safely and reliably in hazardous locations.